Good afternoon, all. Can you hear me?
Yes, madam.
Yes, madam.
Okay. So we were discussing on discrete probability distributions. On the discrete probability distributions, we discussed about 3 distributions. First one is discrete uniform distribution, and the second one is Bernoulli distribution, and the third one is the binomial distribution. So when all the outcome has same probability of getting selected, so it is called a discrete uniform distribution, and the probability distribution is given by 1/n. And then if we consider the Bernoulli distribution, in the Bernoulli distribution we define a Bernoulli trial. So in a Bernoulli trial we have only 2 outcomes there. So if the probability of success is denoted by simple p, and then the probability of failure is 1 minus q, since there are only 2 possible outcomes. So it is called a Bernoulli distribution, right? So the Bernoulli distribution, the probability distribution is also provided. And then the binomial distribution, I said that the binomial distribution is an extension of Bernoulli distribution. So in the Bernoulli distribution we have only 1 trial, but in the binomial distribution we have more Bernoulli trials. It is called a Bernoulli binomial experiment. So a random variable defined under a binomial experiment is called a binomial distribution, right? So we discussed some examples, and also we developed the binomial probability distribution as NCX p to the power x into 1 minus p to the power n minus x for x from 0 to n, right? And then we denoted the binomial distribution using diagrammatic representation, and there we identified that the binomial distribution, it has a property of symmetric, right? Property of symmetric. We developed some equations there. And then since it is somewhat difficult to calculate the binomial probabilities directly using the equation, there are computer softwares that gives the binomial probabilities corresponding to the cumulative probabilities, right? So cumulative probabilities means there you are given the probabilities where number of success is less than or equal to some given number. So that is denoted in cumulative probability tables or either binomial probability tables. Right? So we learned how to obtain probabilities using the cumulative binomial probability tables. And then we were discussing some examples as well, right? So we discussed the first example Monday, I guess. Sorry, part A. So did you try the other parts? So I just wait. So we found the first example, first part. So what is the answer? It is 0.9502, right? 0.9502. Okay. Part B. We want to find the probability where x less than or equal to 2. So it is from the binomial distribution 8, 0.6. Right? So we can write using the property of symmetry, probability of x greater than 6, 8 minus 2. But from the binomial distribution 8, 0.4, it is 1 minus p. Okay. So we can write this as 1 minus probability of x less than or equals to 5. So it is 1 minus 0.9502, which is equals to 0.0498. Right? Then part C, probability x equals 5. So this is for binomial 8, 0.6. So we can write it as probability x equals 3, binomial 8, 4. Right? So using the cumulative probability table, binomial cumulative probability table, we can find this 5941 minus 0.3154. Right? So this is how we use the property of symmetry to find the probability values in a binomial distribution. Any problem up to now? I guess no, right? So I think you can find the answers for the next example. So it is very easy. You can directly use. So this is part 1. You can find the answers, right? We can discuss right? Okay. So in the discrete uniform distribution as well as in the Bernoulli distribution, we discussed the special properties as mean, variance, and moment generating function, right? So we can develop the mean, variance, and moment generating function in the binomial distribution as well. So you know that we can find the mean, mu, using the expected values, right? Expected value of x is the mean of the distribution. So we can write the expected value. We can write the expected value as since this is a discrete one, we are using the summation. If it is a continuous one, we are using the integration. So x into fx is the expected value of x. So we can write the summation from x goes to 0 to n, x into the distribution is ncx, px, q to the power n minus x. That is the binomial distribution, right? So the same expression is repeated here, I guess. So then we know that ncx, we can expand the ncx as factorial n divided by factorial x into factorial n minus x, right? ncx can be written as ncx can be written as factorial n over factorial x into n minus factorial x n minus x, right? Then we can expand here and px 1 minus p n minus x, right? Then we know that we can write this x as x into x minus 1 factorial. This is same. Factorial x is same as x into x minus 1 factorial, right? So we can write x factorial x like that, and then we can cut the x out, this x out. So the remaining part is this one, factorial n divided by x factorial x minus 1 into n minus x. Okay, so now we can take one n out and write it as n factorial n minus 1. That means as we wrote x factorial x, we can write factorial n as n into n minus 1 factorial. Then take n out there and write the inside equation as factorial n minus 1 over x minus 1 factorial into n minus x factorial, right? Then we can let y as x minus 1 and simple m as n minus 1. And if we substitute it, we can write this expected value of x as n is out, and inside the summation, it is factorial m over factorial y over factorial m minus y and p to the power y minus 1 into 1 minus p m minus y, right? So now we can take here, there is p y minus 1, p to the power y minus 1. So we can take 1 p out. Then the remaining part is p to the power y. Okay. So this is the expression of binomial distribution with m trials and y successes, right? So the summation since we are taking summation here, this whole part is equal to 1. Right? So we know that summation all x fx is equals to 1. In continuous case, integration of all x fx dx equals to 1. So the mean is in a binomial distribution is given by NP. So this is an important result, right? So the mean of the distribution, mean of the binomial distribution is given by N into P. So what is N? N is the number of trials and P is the probability of success. So once you know the number of trials and probability of success, so straightforward we can find the mean of the distribution as N into P. Right? So next property is variance. Okay, so the variance could be written as expected value of x minus mu whole thing squared. So it can be written as this. So we know that. And the expected value of x squared can be written as this. So there is no problem, right? Here x squared minus x plus x. So those things cancel out. The remaining part is x squared, right? So x squared can be written using that expression, right? So now we can expand that expression into expected value of x into x minus 1 plus expected value of x minus expected value of x the whole thing squared. So from the earlier knowledge, we know that expected value of x is NP. So if we find the expected value of this, then we can find the variance. Okay, so as we found the mean, here also the same procedure is going to be continued. So expected value of this part can be written as, again using the summation, x, the part here, into the binomial distribution, right? So binomial distribution is NCX PX 1 minus this one, right? That is the expected value of this expression. So like earlier, here also the factorial x can be expanded into factorial. Sorry. Factor x minus 1 into x minus 2 factorial, right? X into x minus 1, x minus 2 factorial. Right? So we can cancel out x into x minus 1 and factorial n. In the factorial n, we can take, as earlier, we can take n into n minus 1 out, and the remaining part is n minus 2 factorial. Right? So After taking n into n minus 1 out, within the summation, this part is the remainder. So as earlier, we let y equal x minus 2 and m equal n minus 2. And then we take p squared out. Since when we do the substitution, here it is p to the power y minus 2. So we take p squared out. Right? So when we let p squared out, again this whole part becomes 0. Sorry, not 0, 1. Then the expected value of x into x minus 1 can be written as this, and we substitute that value there and solve. So it is n into n minus 1 p squared, what we find here, and then expected value of x, it is np, and expected value of x, the whole thing squared, it is n squared p squared. Then finally we end up with this expression. So the variance of a binomial distribution is given by NPQ. Mean is given by NP and the variance is given by NPQ. So I forgot to mention here that here it is x goes from 0 to n. It becomes here x from 1 to n. So when we substitute the value 0, this value becomes 0. That's why we omit 0 there, right? Here also same. If we substitute 0 and 1, it becomes 0. The whole thing becomes 0. That's why we omit x equals to 1. So 0 and 1 there. Right? So the mean of the binomial distribution is NP. The variance is NPQ. So then the moment generating function. We can obtain the moment generating function using the expected value of e to the power tx. And we can write the summation e to the power tx into the distribution. Okay. Then by solving that equation, we could end up with this equation. So the proof is not necessary to use. So just recall this equation. The moment generating function of the binomial distribution is p e to the power t plus q, the whole thing to the power n. Moment generating function. Right? Okay. Then using the moment generating function, we can derive the mean and variance. You know that, right? If we obtain the derivative with respect to r, it gives the rth moment. And let t equal 0, it gives the rth moment, right? So we can obtain expected value of x, that is the first moment around the mean. So we can obtain the first derivative of the moment generating function, d over dt p et plus q to the power n, and then put t equals 0. Then, as we found earlier, we can obtain the moment, first moment or the mean is equals to np, and the second moment we obtain the second derivative of the moment generating function, and then let t equals 0. It will gives us the variance in PQ. So is that clear up to now? So if you are asked to prove, then only you can prove it in the exams. So you can directly use NPQ. If the proof is not asked from you, right? Okay. Any problem? If we don't have any problem, we can move on. Okay. The mode of the binomial distribution. What is meant by mode? You know what is the mode, right? Mode is the value of, here it should be x. Mode is the value of x that is most likely to occur. The mode can be found by calculating all the probabilities and finding the value of x with the highest probability. But it is usually sufficient to consider the probabilities for value of x close to the mean NP. So mode is the value of x that is most likely to occur. Right? වැඩිපුරම සිද්ධ වෙන එකනේ අපි මෝඩ් එක කියලා ගන්නෙ. නේද? අපි for example අපි marks of the student කියලා ගත්තොත් වැඩිපුරම marks ගත්ත range එක ඇතුළේ තමයි mode එක තියෙන්නේ. Right? So in this binomial distribution also, mode is the value of x that is most likely to occur. So we can just answer the mode, we can just find the mode value with the highest probability. The highest probability is the most likely to occur, right? But to find the highest probability value, we have to find the all probabilities for value of x, right? Then only you can find the highest one. We have to calculate all the probabilities related to x. Then only you can find the highest probability. But in binomial distribution, it is usually sufficient to consider probabilities for values x close to the mean of NP. So we know that the mean of the binomial probability is NP. And if we find the probability values close to the mean value, then mode is close to somewhere mean. So that is the concept. So for an example, the probability that a student is awarded a distinction in the mathematics examination is 0.05. In a randomly selected group of 50 students, what is the most likely number of students awarded distinction? So we are asking to find the mode. What is the most likely number of students awarded a distinction? Right? So the random variable is the number of students awarded a distinction in 50 students. So there are 50 trials with the probability of success 0.05. Right? First, you have to find what is the mean. So we know that mean of a binomial distribution is given by the expression NP. So N is 50 and P is 0.05. So the probability is, expected value or the mean is 2.5. Right? So, yes. We are finding somewhere around 2.5 probabilities where x equals 2.5 around some values, right? So we get 1, 2, and 3. Right? So if it is equals 1 from the binomial expression, we can find the probability of x equals 1 is equals to 0.202. And probability of 2 number of students award a distinction in 50 could be found as 0.261. And the probability of number of students awarded a distinction is 3. The probability is 0.219. Right? So you can see that this is a low value and this is a high one. This is again a low value. So this should be the most likely number of students awarded the distinction, the mode. So most likely number of students awarded distinction in a group of 50 is 2. So you can find the mode using the expected value or the mean value. So the mode lie somewhere around the mean of the binomial distribution. It is not so far from the mean. Right? So the mode is close to the mean value. That is the concept. Right? Okay. The next thing we have to discuss is fitting a theoretical distribution. Right? So when you are learning statistics further, you may want to fit a theoretical distribution using the experimental results. Right? So in later, in level 2 or level 3, you're gonna learn whether a given experimental results is tally with some probability distributions or not. So in that case, using the experimental results, we could build up a theoretical distribution, and then using some hypothesis testing, we could say either the experimental results come from a given special distribution or not. Right? So so you have to know how to fit a theoretical distribution. Right? So for an example, so I'll explain it using an example. A biased coin is tossed 4 times and the number of heads noted. The experiment is performed 500 times in all. The results are as follows. So here there is a Bernoulli experiment. The Bernoulli experiment is tossing a coin, 1 coin. Right? So it becomes a binomial experiment since the biased coin is tossed 4 times. So that is the binomial experiment. Right? So that binomial experiment has been repeated 500 times. Right? So within that 500 times, the number of heads occur has been recorded. So within 4 times of tossing a biased coin, we know that we could get 0 heads, 1, 2, 3, or all the 4 times we could get heads. Right? So this is the experimental result by conducting the experiment. These are the results we obtain. Right? So there are 2 questions. First one is find the probability of obtaining a head when the coin is tossed. So it's given that a biased coin. So we can't take it as a fair coin and take the probability of success as 0.5 since it is a biased coin. So first we have to find the probability of obtaining head, the probability of success, right? So if we take the mean of heads obtained 4 tosses as x bar, we know that we can find the mean using summation of fx over summation of f, the frequency. It's a basic knowledge of statistics, right? The mean can be found using summation of fx over summation of f. Right? So if we take that one, we could find the mean of heads obtained in 4 tosses is 2.6. So we just taking here 0 into 12 plus 1 into 50 plus 2 into 151 plus 3 into 200 plus 4 into 87 and divided by summation of f is 500. So we end up with the answer 2.6. So this is the mean of number of heads obtained in 4 tosses, right? So we know that the number of heads in 4 tosses is a binomial distribution. How many trials there are? Since we are tossing 4 times, the number of trials is 4. And we don't know the probability. We are going to find the probability. So we know that the expected value or the mean is NP, and we found the mean. It is 2.6. So we know what is the N. N is 4. So using this expression, we can find what is P. Right? 4 into P equals to 2.6, and then P is equals to 0.65. Right? Then the second question we are asking is calculate theoretical frequencies of 0, 1, 2, 3, 4 heads using the associated binomial distribution. So we are now going to calculate the theoretical frequencies. Right? So to obtain the theoretical distributions, we multiply each probability by the total frequency 500. Right? First we obtain the probability of x, the probability distribution of x. Right? How? Obtaining 0 heads can be found using the theoretical probability distribution. So this is theoretical one, right? This is the theoretical one now. Earlier, the results are from the experimental. This is the theoretical one. So if when there is no heads obtained, it is force is 0. The probability of success is 0.65 to the power 0. into probability of failure, or the 1 minus p is 0.35 to the power 4. So the probability is 0.015. So likewise, we can find the next one as well. It is 4C1 and 0.65 to the power 1 and 0.35 to the power 3. So the probability values are given. So since it is repeated 500 times, we have to multiply these probability values from 500 to obtain the frequencies. Okay, so just multiply. Here it is 0.015 multiplied by 500. So actually the value is 7.5. So we round up into the integer, next integer value, right? Since the frequency value could not take decimal places, we round up the answer to the next integer. Right? So now you can note that the above theoretical distributions, the experimental results, are tally with the theoretical results. The experimental results tally with the theoretical results. Here 12, 50 and 151. Oops, sorry. Here 50, the theoretical experimental one, here 151. See, the experimental results and the theoretical results compares reasonably well with the original frequency distribution. They are being tallied, somewhat close, right? So we can find the experimental results actually follows that binomial distribution using a hypothesis testing, and you will learn them in higher levels, in level 2 or 3, right? Okay, there is a simple example here. Do this example, I'll give you 5 minutes and send me the answers, please. So if you have any doubts on that experimental and theoretical results, you can ask now. Or else I'll give you 5 minutes to do the exercise and send me the answers. So only 2 has sent me the answers. What about others? Send me your answers. Out of those 3, those 2, the first answer is correct. Part A is correct. Check the part 2. It is incorrect. No, Is it that much difficult? It's very easy, I guess, right? So either you can use the binomial table or the expression. You can use both too. If you use the binomial table, since there the probability of success is greater than 0.5, you have to use the property of symmetry. Or else you can use just the expression, binomial expression. So in the part B, you asked to find the probability. So the problem is more than 7 pay by credit card. So X should be greater than 7, right? If we use the expression, you have to find the probabilities where X equals to 8, 9, and 10. So if you're using the cumulative one, cumulative probability distribution, you have to find probability of X greater than 8, greater than or equals to 8. So since the probability of success is greater than 0.5, it is 0.6. In the symmetry, using the symmetric property, you have to find what is P, X less than or equals to 8. Sorry, not 8, 2 from the binomial table. Now it is 1 point P 0.4, 1, 0.4. I guess you have the note, right? I have uploaded it. The corrected one with some additional, with the additional things I have discussed today, I uploaded yesterday. So the answer should be for the part A, up to 3 decimal places 0.011, and for part B, for 2 decimal places 0.17. So you can just try. But I'm not going to do that one. Just easy one. I have discussed all the things. So this is a simple question. So the answer should be 0.011 up to 3 decimal places. Here it should be 0.17 up to 2 decimal places. Try to obtain those answers. So you have to practice, right? All the examples I discussed in the class, you have to practice them again and again. Right? Then only you can understand the things. So actually this course is not very much difficult, but considering the past results, most of students did not pass this module, right? So because of that, they couldn't obtain the degree at the end of the 3rd year or 4th year, since this is a compulsory one. This course is a compulsory one. In the 1st year, you have to learn the maths and stat courses. So those are compulsory. So for the compulsory courses, you should have at least obtain a C grade. Right? If you don't have a C grade, then you can't get the degree at the end. So somehow, when you're 3rd year, or sometimes if you are selected for the special degree or a joint major degree, at the end of the 4th year, you should have at least obtained a C pass. Then only you can obtain your degree, right? So I guess that all of you have read that prospectus clearly, right? හොඳට prospectus එක කියවන්න. කොහොමද දැන් ෆස්ට් ඉයර් එනකොට ඔයගොල්ලන්ට තියෙන ප්‍රශ්නේ ඕක තමයි. කිසිම දෙයක් බලන්නේ හොයන්නේ නැහැ. ඊට පස්සේ අන්තිමේට 3rd year 4th year යනකොට තමයි තේරෙන්නේ ෆස්ට් ඉයර් කාලේ ඔයගොල්ලන්ට කොච්චර දේවල් මගහැරලාද කියලා. දැන් ඔයගොල්ලන්ට දැන් ඔන්ලයින් කරන්න තියෙන කිසි ප්‍රශ්නයක් නැහැ. නැත්තම් මේක ඇතුළට ආවම ෆස්ට් ඉයර්ස් ලට පුදුම ප්‍රෙෂර් එකක් එනවා. අපි දන්නවා ඒක සීනියර්ස් ලගේ. ඒක ප්‍රෙපරේෂන් වලක්වන්න කටයුතු යොදලා තියෙනවා. ඉතින් ඒවත් එක්ක ස්ටඩීස් උත් ඔයගොල්ලෝ හරියට කරගෙන යන්න. බාහිර වැඩත් කරන්න ඕනේ. ස්ටඩීස් තමයි හැබැයි නම්බර් 1 වෙන්න ඕනේ. right? දැන් අපි හිතමු මේ ඔයාලගේ මේ ෆස්ට් ඇටෙම්ප්ට් එකෙන් මේකට ග්‍රේඩ් එකක් ගන්න බැරි නම් A B grade එකක් ගන්න බැරුණොත් අපිට ගන්න පුළුවන් A plus A minus B plus A level results අගෙන B plus B minus වගේ results තියෙනවා. හරිද? එතකොට A එක එක result එකට assign කරපු grade එකක් mark එකක් තියෙනවා. GPA value එකක්, grade point average value එකක්. එතකොට ඔයගොල්ලන්ට C pass එකට වඩා ගත්තොත් තමයි උඩ ලකුණක් හම්බ වෙන්නේ. අපිට GPA calculate කරන්න out of 4. So if you obtain A plus or A for this course or for any course, you will obtain a 4 marks for that. And we multiply it by the number of credits and finally divide by total number of credits and obtain the GPA value finally, right? So අපි හිතමු first attempt එකෙන් ඔයාලට C grade එකට උඩ grade එකක් ගන්න බැරි වුණා කියලා. ඔයාලට මේ කියන්නේ repeat කරනවා කියලා හිතමු අපි C එකක් ගන්න බැරි වුණා. එතකොට ඔයා ඊළඟ attempt එකේදී කොච්චර හොඳට ලිව්වත් ලකුණු 99ක් ගත්තත් ලකුණු 100ක් ගත්තත් ඔයාලට හම්බෙන්නේ ආයි C එකක්. next attempt එකේදී ලිව්වොත් first attempt එකේදී ගත්තොත් විතරයි ඔයාලට grade එකක් හම්බෙන්නේ C වලට වඩා. එහෙම නැත්නම් second attempt එකේදී ඔයගොල්ලෝ ලිව්වොත් එහෙම ආයෙ හම්බ වෙන්නේ C වලට වඩා මේ උඩරිම හම්බ වෙන්නේ C විතරයි. ලකුණු 100ක් ගත්තත් C grade එකක් විතරයි හම්බ වෙන්නේ. ඒ නිසා first attempt එකේදීම grade එකක් හොඳ grade එකක් දාන්න try කරන්න ඕනේ. එතකොට ඒ වගේ GPA එක calculate වෙලා හැම course එකකින්ම අන්තිමටම අපිට එතනදී තව class එක තීරණය වෙන්නේ. එතකොට අපි higher studies කරන්න උනත් මොකක් හරි job එකකට යන්න උනත් හැම දෙයකටම apply කරද්දී class එක කියන එක important. නිකම්ම pass එකක් ගන්නවට වඩා class එකත් එක්ක pass වෙන එක තමයි හොඳ. ඒත් එක්කම අපි second year ඉවර වෙලා special select කරනවා. first year second year අපි සාමාන්‍ය scheme එක විදිහට හැමෝම යනවා. හැබැයි second year ඉවර වෙලා first year second year ගත්ත results වලින් තමයි ඔයගොල්ලෝ special interview call කරන්නේ. එතකොට අඩුමතරම interview එකට එන්නවත් results හොඳට තියෙන්න ඕනේ. repeat තියෙන්න බෑ වෙනකොට. ඔයගොල්ලෝගේ තියෙන ප්‍රශ්නේ first year එනකොට ගණන් ගන්නේ නැහැ. එහෙම බෑ. පොඩ්ඩක් උනන්දු වෙලා වැඩ කරන්න ඕනේ මීට වඩා. right? අතර මේ chat එකේ ප්‍රශ්න අහනවට වඩා ඔයගොල්ලෝ කතා කරනවා නම් මම කැමතියි. එතකොට මට interact වෙන්න පුළුවන් ඔයගොල්ලොත් එක්ක. ඔයගොල්ලෝ අඳුර ගන්න පුළුවන් නේද? පොඩ්ඩක් කතා කරන්න try කරමු අපි. මම කැමති මොනවා හරි presentations හරි මොනවා හරි කරන්න පුළුවන් නම් මම කියන්නේ physically අපිට එන්න පුළුවන් නම් මම නම් සාමාන්‍යයෙන් කරනවා. බලමු අපි. මම හිතන්නේ නැහැ ඉතින් මේ course එක ඉවරනකන් නම් physically අපිට meet වෙන්න පුළුවන් වෙයි කියලා. So work hard, right? Work hard. That should be the number one. So any questions regarding the binomial distribution? So I'm going to end the binomial distribution here. So if you have any question, any doubts regarding the binomial distribution, you can ask now, right? So in this example, at Celtol supermarket, 60% of customers pay by credit card. Find the probability that in a randomly selected sample of 10 customers, exactly 2 pay by credit card. So here the probability of paying by credit card is given as 60%. So using that, we can find the probability of customers paying by credit card is equals to 0.6. Right? So if we take the probability of success, if we take the success as the customer pay by credit card, then customer do not pay by credit card is given by 1 minus b, it is 0.4. So we have 10 customers, that means 10 trials. If we select a Bernoulli experiment as of one customer, so one customer either pay by credit card or not. any method. He can pay online, he can pay using money with their hand and check, any method, but we divided the result outcome into two: pay by credit card, do not pay by credit card. So the success is, if the customer pay by credit card, it is a success. If the customer is do not pay by credit card using any other method, it is as a failure. So if we choose one customer, it is a Bernoulli experiment. So we have 10 customers selected at random. That means that Bernoulli experiment has been done 10 times, 10 trials. So it is a binomial experiment. So out of those 10, what is the probability? Exactly 2 customers pay by credit card. So probability of X equals 2. Here, more than 7 pay by credit card means probability X greater than 7. So just try those examples at home and try to obtain the given answers. Okay. So if you don't have any problems, then let's move on to next chapter. Sorry, next part of the chapter. So now we have learned 3 probability distributions, and in the next part, we are going to learn the geometric probability distribution and negative binomial distribution. Geometric distribution and the negative binomial. This is the binomial. So in next part, we learn geometric distribution and negative binomial distributions. So someone has asked me, can we use that binomial table in exams? Yes, you can use that. You can use either your calculator or the binomial expression, or either you can use the binomial table as well. The binomial table will be provided. But you have to know to do the calculations in both ways, using either cumulative probability distribution or the expression, using the binomial expression, right? Okay. Okay, next distribution is geometric. Next 2 distributions are geometric and negative binomial distribution. So in the binomial distribution, there is a fixed number of Bernoulli trials. There is a fixed number of Bernoulli trials, right? In the earlier example, you may recall that there are 10 customers. 10 customers and 4 tossers. Likewise, the number of Bernoulli trials is fixed there. Number of Bernoulli trials is fixed, and we are calculating the probability where the number of success equals to some number out of the Bernoulli trials, out of the fixed number of Bernoulli trials. what are the possibility of success, right? In the binomial distribution, we are discussing about that. So suppose that we do not fix the number of Bernoulli trials in advance, but continue until a certain number of successes occurs. That means if we, for an example, if we say the rth success, so rth success is going to happen in the xth trial, right? So consider this line here. So this is the xth trial, and it is the yth success. There are x number of trials. So out of those x number of trials, there are y number of, the xth trial is the yth number of success. Before that, y minus 1 successes have been occurred. Xth trial is the yth success, right? The random variable x is defined as the number of trials required for r success. So when r equals 1, it is called as the geometric distribution, and when r is greater than 1, it is the negative binomial distribution, right? So for an example, we are tossing a coin until we are getting head in the first time. So it is a geometric distribution, right? So we are tossing a coin, right? So it is a Bernoulli, we know that it is a Bernoulli trial. Since there is 2 outcomes, one is probability of success. We are taking the obtaining head as a probability of success. Then it is a Bernoulli trial. Tossing a coin is a Bernoulli trial, right? So we repeated the Bernoulli trials until we get a head, the first head. So it follows a geometric distribution, right? So if we continue the Bernoulli trials until the second success, until we obtain second head, third head, fourth head. In that case, the number of successes is greater than 1. It follows a negative binomial distribution. So that is the geometric and negative binomial distribution. So let's first consider geometric distribution. So in the geometric distribution, x is, the random variable is the number of trials required for the first success. Number of trials required for the first success. Palavani success occur when the trials kiyak konada. So in binomial distribution, the number of trials are fixed. Out of these trials, how many successes are there? That is the thing we are concerning in binomial. But is in geometry, we concerning about how many number of trials we require for the first success, right? So for the event x equals to x to be success, it is necessary to have x minus 1 failures. So if the x trial is a success, then the before trials, the earlier trials until x should be a failure one. Failures should be failures. That means, so we have x trials here. See, we have x trials. The x trial is the success one. So all the before trials are failures. So it took X number of trials to happen the first success. Right? Is that clear? Any questions? So we can write the probability. The probability of first success occurred in X trials. So there should be X minus 1 failures and the last X trial success. So X minus 1 trials are the failures. So the probability is 1 minus P. And the last Px success, the probability is P. So there should be a space here, right? It should be 1 minus P to the power X minus 1 into P for X equals 1, 2, 3 likewise. There is a space, right? There is a space. So here we are finding how many number of trials we required to obtain the first success. It could be 1. At the first time, it could be a success. Then first time failure, second time success. And first time failure, second time failure, third time success. So we are continuing the Bernoulli trials until we get the first success. Right? So according to that explanation, we can define what is a geometric distribution. A random variable X has a geometric distribution and it is referred to as a geometric random variable if and only if its probability distribution is given by Px equal X. That means the first success has been occurred in X trial is equals to P into 1 minus P to the power X minus N. For again, there should be a space. Please correct it. For X equals 1, 2, 3 likewise, where X is the number of independent Bernoulli trials required for the first success and P is the probability of success for each trial. So if X follows a geometric distribution with parameters P, then the notation X can be written as GEO with the probability of success P. So if we take the summation of all X, it becomes 1, right? So it's a thing we know since earlier, right? The summation of Fx is equals to 1. Okay, consider this example. According to a representative for an automobile manufacturer, the company uses 300 lock and key combinations on its vehicles. Suppose that you find a key for one of these cars. Find the probability that you would find the correct key in 150th try. So you have to find a key for a given car. For a given car, you have to find the key. So there are 300 number of keys. So you are asked to find the probability that you would find the correct key in 150th trial. 150th trial. That means 149th trials you are failed to find the correct key. And in the 105th trial, you got the correct key. Until that, you failed to find the correct key. Right? So the random variable is defined as number of attempts required to find the correct key. Then X follows a geometric one, since you are concerning about the first success. So the probability can be found. So each and every key has equal probability of being the correct key. Therefore, the probability of success is 1/300. Right? So we need to find probability where the first success occur in the 150th trial. So it is P into 1 minus P and then X minus 1. Right? So P is 1/300. 1 minus P, 1 minus 1/300. X is 150 minus 1. So this is the probability that he found the correct key in the 150th trial. Okay. So that is the geometric distribution. Okay. So the diagrammatic representation of the geometric distribution, as in a binomial one, here we can also represent the distribution using a diagrammatic representation. So we can draw a vertical line graph to illustrate the distribution of X, where X is geometric with the probability of success 0.4, and the state, the mode. We are going to find the mode using the diagrammatic representation. So the geometric distribution is given here. Since X is equals to, P is equals to 0.4, probability of first success occurred in X trial is 0.4 into 0.6 to the power X minus 1. For X equals 1, 2, like that. So when x equals 1, that means the first trial is the success one. The first trial success one. So in that case, x is equals to 1. So it's just 0.4, right? Because 0.4 into 0.6 to the power 0. So it becomes 0.4. So the probability of the second trial is the first success. It is probability of x equal 2. So now it becomes 0.4 into 0.6. That is 0.25. Right? Then, so this is equals to 0.4 into 0.6. And probability of third trial is a success. Third trial is the first success. So it is 0.4 into 0.6 to the power x minus 1, 3 minus 1, it is 2. So it is 0.144. Right? So the most likely value in any geometric series is 1. So this is the cumulative one actually. This is the cumulative one. So if we draw the normal line graph, you may see that always the probability of first success occurred in first trial is the most likely value. අපිට පල්ලෙහාට එන්න x ගේ value එක වැඩි වෙන්න අපි දන්නවා මෙතන probability of failure කියන්නේ එකට අඩු වගේක් හැමදේම. එතකොට එයාගේ powers එනවා කියලා කියන්නේ එන්න value එක අඩු වෙනවා. Right? So the most likely value or the mode in any geometric series is 1. Right? Okay, any questions? So we have to discuss 2 properties there. Yes, someone has asked me to explain it again. So here, the geometric distribution is this one, right? So if we substitute values for x, we can obtain these results. So the mode is most likely value. වැඩිපුරම වෙන්න පුළුවන් value එක තමයි mode එක කියලා කියන්නේ. එතකොට වැඩිපුරම වෙන්න පුළුවන් කියන එක අදහස් වෙන්නේ the maximum probability. So in geometric distribution, always the maximum probability gives when the first success occurred in the first trial. X equals 1. Why? When x is increasing, we got here the x minus 1 value is also increasing. x minus 1 value. So we know that here the probability of failure is a number always less than 1. So a power of number of less than 1 value is always become smaller when power increase. So when x equals 4, it is 0.6 to the power 3, right? So 0.6 to the power 3 is a lesser value than 0.6 to the power 2. So those values are always multiplied by the p. Probability of success 0.4 for the same value. So when x increases, the probability decreases. So the maximum probability always is when the number of when the first success occurred in a first try. So the mode in any geometric series is 1. 1 වෙනකොට තමයි හැම වෙලේම වැඩිම probability එකක් තියෙන්නේ. So now I think you get it correctly. Right? So we have only 10 minutes, right? So I think let's continue this tomorrow, right? Yes, you got it now, right? Okay, right. So let's continue this on tomorrow. Tomorrow 10:30, 12:30 you have the lecture, right? I guess I need only 1 hour period. So let's continue it tomorrow, right? Question. There is a question, right? Talking B part of plastic size binomial distribution. Having greater than 7. Binomial. So it should be greater than 7. That means 8, 9, and 10. Right? So probability x greater than 7 means it is equals to probability of x greater than or equal 8. Right? Then using the symmetric property, it is equals to probability of x less than or equal 2. X number of trials minus the number of successes. But it's from the binomial 10 to 0.4. Right? So greater than 7 means 8, 9, and 10. So 6 or less than. No. You have to take the explanation I am given, right? Right, okay. Is it clear now? So I think it's better if you are asking a problem via chat. It is visible to everyone, right? මොකක් ප්‍රශ්නයක් අහනවා නම් හැමෝටම පේන්නේ. කියන්නේ පොදු ප්‍රශ්නයක් නහන්නේ අපි ප්‍රයිවට් මුකුත් නෙවෙයිනේ නේද? ඒක නිසා මේ ඩිරෙක්ට් මැසේජ් එකකට වඩා to everyone දැම්මොත් අනිත් අයටත් ඒසි වෙයි. මොකද්ද මේ අහන්නේ කියලා දැනගන්න. Okay. So any questions? Okay, I guess no then. So let's continue this tomorrow. I hope to finish finish this part 3 tomorrow, and there are some other distributions, exponential distributions. There are some more distributions and the discrete probability distribution. So let's try to finish this part tomorrow, right? Okay, then thank you for joining today. And if you have any questions, you can send me an email or WhatsApp message, right? So I'll give you a date for the made up quiz, those who couldn't participate to the quiz number 1. So keep in touch. Okay. Thank you for participating.
Thank you, madam.
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 Madam.
Okay, you are welcome.